Hello, everyone. So, very good morning to all of you. Okay, so today we'll have one more interesting session on one of the, you can say, most exciting, or you can say the topic that is number theory. This topic is actually the favorite topic of mathematician to do research. Okay, so that we'll be discussing about number lines and about zero. Okay, so we'll start the session in, let's say, 2 to 3 minutes, and then we will proceed further. Okay, so let everyone join us. So, to make this session more interesting, I will give you some questions or some brainstorming thoughts that you have to think on your own, first of all. Because in the session, I'll discuss, but still, first of all, you have to think of a number line that you know about zero. Then you have the left and right hand side you have 1, 2, 3, 4, and plus or positive, and then in the right hand sorry left hand side you have the negative quantities -1, -2. In terms of integer, you have to think. Okay? Now you have to give an your opinion that is actually zero is neutral or not, because see, when you discuss the whole number line, okay, so we have 1, 2, 3, 4, 5. These are called positive numbers, positive integers. -1, -2, -3 up to, okay, minus infinity. Actually, infinity is not a number, but -1, -2, -3. These are called the integers. And the zero is neither positive nor negative, as you know, and it's actually called neutral. It's actually zero is neutral or not, or it is something which is just confined to a certain system. Okay, or we can make zero non-neutral quantity. Okay, because if you will think on it, let's take two positive integers. Okay, like 0, 2 and 3. Okay, the difference between 2 and 3, absolute difference I will take it. That is 1. Okay, now you take 0 and take 1. Okay, the absolute difference you have to take. Again, you are getting 1. But when you are taking 2, 3 or 1, 2, these two are, the difference is same. These two are positive integers that you are seeing the positive integers. But when you are taking you are getting the same difference when you are taking the same operations with 0 and 1. And here the 0 is neutral. So this is something where, okay, this is the one question, that is it possible to define 0. Second one, can we define 0 independently without taking the help of any other, okay, mathematical tools? So that you have to think. This is about the existence of 0. Okay, now can we think of a number line where this 0, 1, 2, 3, 4, or -1, -2, -3, -4, these all system just gets reversed or altered or become different from it, from the standard system where we are taking the 0 as the, you can say, simply what we are doing actually, we are just keeping a mirror. Okay, suppose you are taking a plain mirror, uh, not plain mirror, plain mirror will do different thing. Okay. So actually it is symmetrical. Okay, mirror, mirror image we can't say actually, because one is +1, one is -1, so they are symmetrical, you can say. Okay. So that's the 0 is. Okay. So how can we define 0? How dependently? How independently? That we are going to discuss. Okay, and itself how can we define 1, 2, 3? These are some quantities, okay, or numbers, integers, which are definable using some extra advanced method. It means that we are discussing number line. This is very elementary concept actually, which is actually you can say about integers in sixth standard. Okay, hello, connection is unstable. That is true. Wait. Just wait for 30 seconds. I'm checking whether I'm audible or not. Okay. Okay, it's fine. So we are discussing about how can we define other now integers 1, 2, 3, 4. Okay, using extra advanced mathematical tool. What do you mean by extra advanced mathematical tool? Actually, the extra advanced mathematical tool that I'm saying. Okay, what is it? So you are discussing a number line. We are discussing number line. So the concept of integers. Okay, these are introduced in sixth standard, as per my knowledge. Introduction of algebra. So you study this number line, this integers at a very elementary level. Okay? And using the advanced mathematical tools means using the concepts of limit. Okay? Relatively, it's advanced concept. So we will have a very uh, interesting and unique session on number line and zero. Okay, so these topics are actually very underrated, and actually people think this as a very simple and the topic where the discussion should limit to 1 minute, 2 minute, 5 minute, 10 minutes. These topics, actually, the section number theory is actually a great area for research. Okay, so because the concepts are some uh, areas of this number theory are quite deeper than what we think, like number line only. Okay, you are just discussing zero and then you are discussing 1 to 0. But the number line, the concept of number line is quite beyond this. Okay, the concept of zero, actually zero and infinity. These are the two, uh, I would say, quantities which we very rarely discuss because we don't. We just say zero is something. Even the thumbnail is zero is nothing or everything. Okay. So what we say is as zero, that zero is neither positive nor negative, zero is neutral and all. We say the zero has a very huge power, that if we write 1 and then we write 0 in front of it, in the right hand side the value increased by 9 and all, whatever. These are okay, these are acceptable, but still these are not that advanced or that, I would say, thoughtful thing. Okay? Because everyone can think that if we have 1 rupee, we have 10 rupees, we have 100 rupees. Everyone is knowing that if we are applying 0 in the right hand side, the value is increasing. So that is quite obvious also. So what we are discussing is not that obvious, but after the session it will be obvious. Okay, so let me share my screen with you and then we will begin our session. Okay. And one more thing, anyone can join this session. Okay, there is no any what you say prerequisite for it, so anyone can join. So here we go. Okay, I think the screen is also visible to you. Fine. So we will start with your standard number line, okay, and then we will extend the concepts. So just drawing a simple number line, and again the number line is also not a line segment, it's a line, okay. So itself the name suggests that it's a line, not a line segment. So it will go to up to infinity here, and on the left hand side up to minus infinity. So the length is infinity only. Infinite, this is something a line segment you are drawing of infinite length, that becomes the line. Okay, so that's number line we are discussing. So this is your standard zero, okay, and then you have 1, 2, okay, here in the left hand side minus 1, minus 2. Okay. Now this particular number line, this is called standard number line. So, standard number line. And the number line which we are discussing in the today's lecture, okay, or our discussion will be confined to an integers, okay, because if we'll extend it to, let's say, rational number, then even between 0 and 1 we'll have rational numbers, and uh, 1 and 2 we have fractions rational. So we are just discussing uh, considering the integers, okay, 0, 1, 2, minus 1, minus 2. So integers we are considering positive, negative integers as well as 0. That's it. Now what actually the 0 is? We'll take one more. So even the concept which I discussed with you, the negative dimensions, I think in the last lecture, that is also related to the today's lecture in some way. Because what you are seeing that, suppose we are standing here, okay. So as we are moving in the left direction, okay, or yeah, left direction only. So what is happening here? The value is decreasing. You can see this is not that advanced thing. The value is decreasing. So 3 is decreasing, 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 and here it resets to the 2, then to 1, and then to 0. So actually, what is 0? There are different interpretation of 0. But what happened that when you are reaching from a very high value, here I have taken 3, okay, you can take 5, 10, 11,000 crores, 10 crores, okay. What is actually happening, or you take infinity also. So what is happening that when you are moving from a very high value, let's say infinity, okay, we will also describe it in terms of negative quantity also. But don't worry, first of all let's discuss about the positive, okay, and then about the uh, more possible number lines that we'll also discuss. So don't worry about it. So what happens, suppose we are taking the plus infinity, okay. So what actually 0 is, that I'm trying to make you feel. So the value that is infinity, we are coming from that, and we are moving, and as we move towards or in the left direction, the value is decreasing. Suppose here we are taking infinity as 3. Suppose we are taking infinity as 3. Infinity is a very large value. I can assign any value to it. I am taking infinity as 3, suppose. So we are coming from 3. Okay, we have crossed infinite numbers. before we reach 2. Okay, because as we are discussing integers only, but while explaining the concept of 0, because 0 is common to whatever you are saying, integers, rational number, everything. Okay, real numbers mainly. So it is common. Okay, so actually when you are coming from infinity, that I am taking as 3, you can take any value, because if I am explaining it with respect to infinity, it will be little difficult. So to just simplify it, we can take infinity as, you can take as 1 crore, you can take as 10 crore, you can take as 10, you can take as 5, you can take as 3, which I am taking. So when you are coming from 3, you are moving in the left direction. Okay, you are crossing again in finite numbers to reach a number or an integer just lesser than 3, that is 2. Again I am repeating. So when you are traveling, when you are walking, suppose you are at 3. Okay, and now you are walking in the left direction. Okay, then you are actually crossing infinite numbers. Okay, to reach 2, which is an integer which is just lesser than 3. Okay, so actually in the journey from 3 to 2, you have had already crossed infinite numbers. Okay, so then from 2, let's discuss it. From 2, now you are making your journey in the same direction without altering the direction, the left direction only, and now you are again crossing different infinite numbers. What do you mean by different infinite numbers? Between 2 and 3, we have 2.0, 1, 2.1, 2.2, 2.3, okay, 2.7, 2.9, 2.87, whatever. So when you are traveling from 3 to reach to 2, you are crossing infinite numbers before you reach 2, which is actually the integer which is just lesser than 3. But when the traveling is same, when you are walking in the same direction, in the left direction, but from 2 to 1, you are again crossing infinite numbers, but these numbers are itself different. Okay, because between 1 and 2 you have 1.2, 1.3, 1.3, 1.4, which are not same. Actually they are different from 2.3, 2.4, 2.7, right? So now your journey started from 3, you reached to 2 after crossing infinite different numbers. Then from 2 to 1, again different type of infinite numbers. And now from 1, you are actually again traveling in the same direction, that is the left direction, to reach to 0. Okay, so called 0, by crossing, by passing through again infinite numbers that are different from your journey between 1 and 2, or you can say the journey between journey from 3 to 2, 2 to 1, and 1 to 0. In all these intervals, you can say, you can take 0 to 1, you can take 1 to 2, you can take 2 to 3. The numbers which you are crossing, they are infinite numbers, but they are itself different. Like 1.2 is not same as 0.7, or is not same as 2.7. So that's the fact here. So actually 0 we are not explaining independently actually here. We are explaining it using a number, let's say 3. So actually 0 is the form of 3 only. Little you can shocking, but 0 is actually the form of an infinite numbers which it traveled very 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 long journey, and then it reached to a certain point where the value collapses to 0. Okay, So this is the definition, one definition of zero, uh, using an integer 3 or any integer you can use. You have to define the same way, same infinite numbers you have to cross and all. That's it. Now, an easier version, okay, that I feel. Zero is the integer which is just greater than minus. Something happened, no? Let me check. System is eating. Let me check, okay? Just give me 10 seconds, okay? Okay, so yeah. So the easier version to define a zero using other quantities only, other numbers only. We can say it's the integer which is just greater than minus 1 and just lesser than 1. So it's an intersection that when you are discussing a coordinate system, remember this. Suppose you have, let's say this has x-axis, this has y-axis, and suppose you are drawing a line y is equals to 2, okay, and x is equals to 3. So how you are defining 3 comma 2 here? You are defining 3 comma 2 as the point of intersection. Okay, let me write first. You are defining 3 comma 2 as the point of intersection of two lines. Okay, that is x is equals to 3 and y is equals to 2. Where y is equals to 2 is actually you are actually drawing you when you will draw the tangent, it is looking like this. Actually, it is of slope 0. Okay, and this particular x is equals to 3 is of infinite slope. It is a steeper. Okay, so how you are defining 3 comma 2? You are defining 3 comma 2 as a point of intersection of x is equals to 3 line and y is equals to 2 line. Okay, x is equals to 3 and y is equals to 2. Similarly, we are defining the 0 as the integer which is just greater than minus 1 and lesser than 1. So the intersection of the those two conditions will be 0. Okay, that's 0. Again, you can travel the same journey using the negative quantities, like from minus 3 to minus 2, then minus 2 to minus 1, then you will reach 0. Now, now comes the question. I think I discussed with you, I asked from you actually, about definition of 0 and neutrality of 0. Yeah, let's discuss it. Actually, the number line which you are actually drawing this is not the general form. This is standard form. Okay, this is a standard number line which we use while making our discussions. But there are several infinite number lines possible that we can draw and make interpretations. Okay, so suppose we are drawing a new number line. Suppose this number line is n, and we are drawing a new number line that is n dash or n hash, whatever you say. Now, in the new number line system, as I discussed with you, the concept of the definition, that we can assign a new definition to a new system, and furthermore, we can explain the whole concepts. Okay, so the same ideology I'll be using here. So just have a look on it. We are defining an n dash system. So let me first make you clear with the definition of n dash system. So it is not n, it is different from n, so n dash. And here in the older system, one, suppose is equivalent to here 0 dash. If you have attended my last lecture, okay, then you are aware with this type of definition. This is called uh, assigning definition while defining a new system using equivalent. Okay, so these uh, three signs, these you can say a line in this way is actually equivalent. Okay, the sign of equivalent. Equal to is just this one, two lines like this. This is equal to. This is equals to. Okay, equal to. But this is actually the equivalence. So we are defining a new system that is n dash. Okay, and in this system we have defined that in the older system the minus one which we are saying, that is actually a 0 dash or the S neutrality. Okay, here we see that actually 0 is not neutral. How can we prove that? How can we show that 0 is not actually neutral? Because we can define a new system that is n dash and double dash whatever and power 5 whatever and power square. We can define a new system. Even n power square, if you are defining that, mean a different thing, so don't get confused with n dash and double dash whatever. So it will mean a different, it will be a different system where we'll have to assign a definition to run this system. Okay, so we have defined that the in the older system the minus one that was there is actually equivalent to 0 dash in this new system. Okay, so now furthermore we can have the interpretations with respect to this definition. Okay, because actually what we are saying 0 dash is the neutral 0 that we say, so called neutral 0 in n dash system. But in the other system, in the older system, the same 0 dash which is acting as the neutral quantity, neutral 0 in the n dash system is actually a negative quantity in n system. So that is minus 1. So minus 1 is a negative quantity, so but 0 is neutral, so 0 dash is actually 0 dash in n dash system. If we are defining, so we are defining 0 dash as a neutral quantity, neutral 0 in n dash system, but the same is equivalent to a negative number which is in n system, that is minus 1. Okay, so minus 1 is actually equivalent to 0 dash. So now we can have the new number line, okay, definition of new number line, which we can use. So actually this particular, even the this statement only, this I would say minus 1 equivalent to 0 dash, this itself shows that 0 is no longer neutral, because actually the 0 dash is the neutral. See, it means that if 0 we are defining as a neutral in one system, it is not necessary that in another system it will be the neutral only, because actually we are saying that 0 dash is a neutral 0 in n dash system, but the same 0 is equivalent to the minus 1 in the another, in the first system, which is a negative integer. That's the thing. So we can define now. Just see, if we have to say what is 1, we have to say 1, or suppose we have to go by this way, 0. Okay, 0 in the older system, what will be? It will be equivalent. So what you are doing, you are just using an operation here, you are just adding plus 1 both the sides. So what it will be? What it will be? It will be 0 dash plus 1, and this is actually equals 1 dash. How? Just look at it. You can make direct also, that minus 1, if we are making an equivalent as a 0 dash, then we can say that the 0 is actually 1 dash. But using mathematical rules, we have to just add plus 1 both the sides. So actually this is that again extension of definition. The definition which we assign to the new system is just the extension of it, nothing more. So 0 dash plus 1 is 1 dash. So now our new system will look like this. I'll compare the from the previous one also. So just look at this okay, under this one. This is an dash, 0 dash, 1 dash, 2 dash. Okay, minus 1 dash, minus 2 dash. So if you have to compare the whole both the system, then you have to uh, draw the number lines in the what sense, symmetrically, or even not symmetrically, but you have to show that this 0 dash is actually equivalent to 1 minus 1. Okay, so actually here it will be minus 1, here it will be 0, here it will be 1. Okay, and here it will be minus 2 only, because we can say that minus 1 dash. Okay, so actually we are subtracting from here, minus 1 is okay, fine. So minus because here now this 0 dash, this minus 1 is equivalent to 0 dash in the other system, so it will look like this. Just okay, so now this minus 2 dash will be equivalent, minus 2 dash equivalent to minus 3. Getting? Fine. Okay, so two different system we have defined, n and dash. Okay, so from this discussion we actually you can say shown that 0 is no longer neutral, or you can say the neutrality of 0 is not fixed. It can vary with the definition with the new number system. Okay, so now comes the definitions of some more, or you can say using advanced mathematical tools, how can we define 0, or how can we define the you can say 1 and all. So I'm just taking a smaller look. That is called using limits also. You can, okay. There are several methods you can use also. That's not that special to discuss. Like suppose we are taking a limit. Okay, let's take an example. Limit x going to 0, extending to 0. Sorry, going to 0 is also fine. Sine x over x. What is it? It's going to give you 1. Okay, if you know this limit, or you can solve using L'Hopital. So we can define 1 as the value of limit when a variable x is going to 0 or tending to 0 uh, with sin x by x. This way you can define 1. We can define 0 also similar way. So these are not that using, because when we have defined 0 using that concept of traveling, so that is obvious, and that is not using so much mathematics, that is just using that number line only. But here we are using limits, we are using trigonometric sin x, we are using variable concept, so it's advanced as compared to that. Even we can define minus, you can define half also, minus 1 also. So in the similar way we use the definition of limits or the advanced mathematical tools, so we can define these quantities, because itself 0, 1, 2, 3 absolutely they are not having any definition that you can say that we can define 0 independently without using that will, okay. So Actually, you can't say that I can define zero independently. Okay, you have to take the help. You can use that journey in the working method. You can use minus one and plus one, okay, concept. So zero is that unique. Okay, so zero, when you would see the exact structure, exact shape of zero, that is actually oval or elliptical. Okay, whether you say oval or elliptical, more or less similar to each other. So actually, this is if this is zero and this is elliptical, this is not actually zero. Suppose the zero is elliptical. Leave it. So zero is suppose elliptical. So in ellipse, what happens? There is a symmetry. Okay. So that way you can also see the zero. But the neutrality of zero is not fixed. Can vary with the different system. That I think you got. Some more points we discussed also, like the number line, then the journey discussion of how we can reach zero, what is actually zero, so the infinite traveling from 3 or any higher quantity to then we reach actually zero. So that's the one thing. You can use the limit definitions also. So these are the ways we can actually define the zero, and this is actually the number lines concept and the definition of, we can define redefine a number line and we can call it n dash and n double dash and whatever. So this was, I think, all for this session. Okay, so let me check first of all. Okay, so that was the mystery of number line, that it can be redefined also, and about the zero and the definition of zero. So thank you so much for joining me in this session. I'll plan soon the new session, but in the upcoming weeks, actually the next week, I'll be a little busy. So maybe this schedule will be a little altered. So sorry for the inconvenience. Uh, Here, and I'm just ending the system and 10 seconds ago. Okay. I think you enjoyed this session. Okay, little learning. Thank you. Bye bye. One, two, three, ending.